Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about opposed piston engine. So let's dive deep into it. Now, what exactly is the problem that we need opposed pistons, so to say? Well, here's the deal. If you understand combustion, you will understand one core component. Temperature and pressure are tightly linked, meaning you cannot affect one without the other. As in, if you're like, okay, you need pressure to do the work, cool, awesome, but you do not want heat. So you're like, okay, what if I cool it? Here's the deal. Pressure will also drop. So they are very seriously intercoupled. And again, this is another reason why in rocket engines we overflow one component. We do not need basically high temperature, we need high flow. So in those sort of scenarios, we are utilizing that excess heat. Here, you also have that same problem. It's like, okay, the cylinder heads, what if you cool the hell out of it? Here's the deal, your engine will literally lose performance. So fundamentally, you want temperature to be stable so you can have pressure stability. And what was the easiest way to solve that? Well, surface area to volume ratio. For example, let's assume you have one. It does not matter 1 centimeter, 1 meter or kilometer. You have one, right? A cube that is 1. Here's the deal. The surface area would be 6 and the volume would be 1. But here's the deal. What if you make it bigger? So let's assume you made it 3 meter by 3 meter. And then surface area will become 54. Surface area is huge. Basically, how quickly it can dump heat is become huge. It has 54 units of a place where it can dump heat. But here's the volume went to 27, meaning surface area to volume ratio is now better. It's 2. It started with 6, went to 3, went to 2. Here's the deal. If you making it bigger, the surface area to volume ratio will start to go into 0.1, 0.05. So you can reach a scenario where the place where the boom is happening, the actual combustion, it has enough volume to do its work. Like it's like pressure pushing, and the surface area that will leach the heat away goes down drastically. Okay, that gives you a reason why you want to make a very long travel cylinders. And specifically, this is why you want to do what we call under square engine, meaning you do not want your piston like F1 going. You want it to be like long travel. The longer the travel, generally the more efficient engine it would be, and more torque also you're going to get. So it's a very good, from thermodynamics point of view, it is very good. But that itself causes a problem, meaning now you have a travel that is so long, the piston speed is very high, meaning for example, a large container ship engines, the piston is literally, the diameter is around 1 meter, as in the bore, and the travel is 2.5 meters stroke. So that is a very long travel. So they can only rev up to 100 to 200 RPM. If they try to do even 500 RPM, the velocity will become like stupid. It will literally shatter because of the velocity. So what makes thermodynamically more efficient engine also makes engine poor in terms of power to weight ratio, meaning your engine has to become big in order to compensate. Opposed piston is a cheat code on that. It's like, what if you get very long travel, but again, each piston itself is traveling very short distance, but the overall expansion is huge, meaning you can harness more useful work out of a combustion event. Same amount of fuel used, but you can get more work done without having the penalty of pistons traveling very fast, which will create a penalty of reducing the speed, reducing the RPM and making it bigger. So that's how somebody figured out opposed cylinder engines. Now, bore to stroke ratio becomes good without the penalty of stupid, basically RPM penalty and all that. So that's why we want to generally have very huge bore to stroke ratio. But we also don't want to suffer any penalty. This puppy allows us to do best of both worlds. So how does this magical technology works? Well, this was the big deal. Basically, once we figured out aircrafts, people wanted to make aircraft. But we realized very early on, even though aviation was growing, it was not growing actually because we could not go further. So what was the limiting factor? Well, power plants was the limiting factor, as in like who is providing the main hot spa. So powerful and efficient engine was the key. People could have made big engines. They did try to make big engines, but even if they could get it to fly, the fuel tank would be drained very quickly. So it turned out very quickly that you have to not only make engine that is powerful, but efficient. So you do not reach a scenario where it's like, okay, the engine is powerful, but the fuel tank is so heavy it can't fly. So in those sort of fertile ground, especially after World War II, during World War II, basically opposed piston became the love darling of all. As in two-stroke systems, meaning you does not have to worry about valves, trains and all that. So it's much simpler, and you basically use ports. How the heck you have basically piston opening and closing before one another? Well, you simply have ports exactly where you need to, basically at the bottom dead center, and you have one that is for exhaust, one for intake. But here's the deal, how do you sequence it? Somebody figured out this, like what if you rotate the crank offset, as in the crank itself is sync, right? Generally you will think both of the crank are sync. No, they are generally offset by some amount of degree based on design. So you can do it such a way that exhaust opens first, then the basically intake. Now benefit of that is combustion event creates a lot of pressure. That pressure wants to equalize. Where it wants to equalize? The outdoor is 15 psi. The boom event happened, let's say 200 psi or even more than that. So you have very high pressure after the expansion. It still is high pressure. It still wants to go out. It goes out. So this 200 psi starts to go out, but here's the deal, it will only go out till it drops to 15 psi. How the heck you scavenge the system? You have to introduce what we call boost. How you do that, that's up to you. Some designs, older designs used supercharger. The newer designs use turbocharger. So that's how you scavenge it. Basically, once the air intake port opens up and the pressure has dropped to 15 psi, the boost pressure flows everything out. It's like, go away. And generally, it's what we call uniflow scavenging, meaning air comes in from one side and goes from the other side. It's a very uniform. It's not turbulent. It's a very flushing. It's almost flushing. So, but again, this engine design does not work. It's not naturally aspirated. So you must provide it boost. It can support its own boost, but you must provide it boost. Otherwise, it will not work. So this will be exhaust. This will be intake, and you do not have to worry about it. In this engine design, they had offset by 11 degrees, so to say. Now, it was a very successful engine, basically successful as in it did what nobody thought possible, as in an engine that had efficiency while providing the horsepower. Let that be very clear. There were much more powerful engines. It was just not efficient. This unlocked the door, was like, hey, you can have very high power engines and also have high efficiency. And this design, the triangle design, be mindful, some people actually tried to make a full square engine. Triangle became far more popular, but that was also done. And the amount of horsepower you can get out of this puppy at that time, as in like 1950s, was unmatched. And be mindful, jet engine was just coming into the picture, so to say. This was so powerful that after World War II, UK was like, okay, we have a lot of like torpedo boats and all that. It's like, okay, what if we swap the German Mercedes engine with this puppy? Yeah, it started to fly. And again, some locomotives also have that. Like it is brutally powerful. You would think like, oh, it's an old engine. No. This is a new engine. It's efficient, it's powerful, and like power to weight ratio is like good. So it's a working system, much simple, much more robust. Although your cranks and all that, they do have to handle twice the power. It's almost like a crank of a V engine in this design. In that design, you have two lightweight cranks of an inline design. And the primary reason of needing strength is simply because of the crank offset. It does not have perfect cancellation, because again, to make sure your ports behave as they should, you have to offset them. That creates a bit of a vibration. Now, that was the old days, but there has been a recent revival, so to say. So there is this company, Achates Power. Now, this company was founded in 2004 by Dr. James Luckman. That's long ago. And here's the deal. He kind of realized that all other people are also realizing that opposed-piston cylinder engine, the brake-specific fuel consumption, like they consume it like how much horsepower per hour, like what kind of fuel consumption would be there. It was unbeat even today. Like it's good. Like for a piston engine, it's like you can't beat it. That's how good it was. So they're like, okay, why not bring it to modern time? And so they started with opposed-piston, two-stroke diesel system. And modifying the piston crown is the new advantage they have. As in, opposed-piston cylinder technology, it's a known system. But the crown, basically, they are modifying the crown in such a way that it becomes a proper combustion chamber. Not a piston that is trying to, like, there is one side flat and then you are doing your best to extract more. No, you have control on both sides. So what if it almost becomes like a sphere. In that sphere, they are squirting fuel. So they are getting complete boom event. And benefit of that is, it has very low NOx emission. Because again, if you can combust basically fuel very quickly, rapidly, you're just like done. That will reduce NOx simply because even if temperature is high, the dwell time is not high enough. As in, like, there is not enough time for nitrogen to get married to oxygens in the air. So it's almost the same principle that newer F1 is starting to almost mandate, that is basically jet ignition. So if you can go very quickly, you can reduce NOx even in a diesel system, even though you have ludicrously high compression ratio. So that's the advantage they have, because they are sculpting the combustion volume. So they're getting that, and they actually made small units and big puppies for trucks. They actually made it and actually sold it. Not sold as in like, thousands of the units sold. Sold as in like, no, take it and prove it. And apparently it was good enough that US Army started to select them for Advanced Combat Engine, aka ACE engines. Basically, America wants to upgrade all their tank engines and Bradley engines, so they did that. But here's the deal: this company is small. If Army comes along, it's like, hey, I need 1,000 units. This company will poop itself. So they're like, okay, Cummins will become their partner. Cummins will do the tooling and manufacturing, all that. So Cummins is the one that is giving Army the guarantee that we can actually deliver it, and the technology is coming from this company. Opposed-piston 2-stroke diesel system, Achates Power. So. And again, Cummins is one of the big puppies. As in, if Cummins says it can be done, you better believe it. Like Cummins, Scania, there are only few companies that are that scale, and they are like, we done, bro. We good. Like, you put that name, you done, go home. So that's the whole point of it. And again, it also has 2 cranks. Both of the crank feed into main master flywheel. Master flywheel, you can leach energy from there. And it does require direct in-cylinder fuel injection. It can work on variable fuels, as in like you can have petrol, diesel, and whatever have you. Then we come to INNengine, INNengine. This is a newer company that started to work on 2011, founded in Spain. They are the same company, but again, I have to say, love it or hate it, they did successfully convince the world that this is a 1-stroke engine, which it is not. Even they know it. They actually clarify. If you ask them, it's like, yeah, it's a 2-stroke engine. It's just for marketing. Somebody said that, and they're like, okay, they ran with it. It's a 2-stroke engine. Same design. Let that be clear. Almost all opposed piston system will be a 2-stroke system, because I've not seen even a theoretical design where you can have a valve that is opening and closing. Because again, puppet valve, you have to machine a compound curve on a puppet valve. Not recommended. So fundamentally, 1-stroke engine, which is a normal 2-stroke engine, but it has lobes. This is a crankshaft free engine, as in there is no crankshaft. They have lobes. It's almost like how CV engine has lobes to dump first surge of power, as in like piston goes boom and it starts to move. The lobe carries the energy into rotational energy, then the teeth, then another roller. So pin A puts the energy into lobe. Same thing is happening here, but there is no teeth here, so it's always lobe into lobe. So penalty, torque transmission is poor, as in this puppy would need a certain level of RPM to do the hot spa. That puppy is known for torque. That's the only thing it's good for, as in even at very low RPM, it has enough oomph, enough torque. It can just brute force it. So loops for reciprocation to rotational conversion, and it does work with one bank of cylinders only, meaning this is the design that they are showing, where they have like A and B side. What if you do not need 8 pistons? What if you only need 4 piston? They can work with this. Right now the market is hot for drone engines, so they are bringing out 4 piston 4-cylinder normal, basically 4-cylinder system for drones. It does not, again, it has the same lobe system, but it does not have what you call the opposing piston. How they are opening and closing, if you watch their animation, they're like, okay, it's proprietary. Most likely it's using the 2-stroke ported piston. That was a design in long ago. We used to use that, where the piston itself had holes. That holes were opening and closing the intake and exhaust. So most likely that's what they are using. So that is in an engine. Now again, it's a cool engine. It does have very low vibration. Again, not zero vibration, because again, they also have to do the same offset. They have to offset it. If they do not, the intake and exhaust will open at the same time. Not recommended. So that's why if in their demo, they have a coin and coin starts to rotate. It has that vibration. Low vibration, not zero vibration. But I do not like this design in terms of scale power. Like I can easily see it drones, maybe a range extender, but like the oomph, because if you're like, okay, I need 16 cylinder, like, or 16 piston even. Yeah, how will you scale it up? Like scaling it up in multiple dimension, it's like not really logical. Like geometry wise, like that. I'm not saying physics stops it. It's just that how will you manufacture it? How will you ship it? How will you assemble it? So it has a very what you call sweet spot, basically from small drone engines to medium-sized car engine, but I cannot see it becoming successful for truck engines. And again, the penalty would be like they have to gear down a lot to get the useful torque. So INNengine, that's another company that is making opposed piston as a comeback, so to say. So what can we expect in the future? Well, reality is it was the sweetheart of the world. As in back in the like 1940s, you said I worked in Opposed-piston surf sign up here. Like if jet engines would have not entered the market, this would have been the king. The end. Flat out. It had the power, it had the efficiency, and all of that in one package. And be mindful, the parts count for the horsepower was actually lower. So it was really good. But again, aviation jumped to jet engines, and these were designed from day one for aviation use. Penalty, they were big puppies. And again, big puppies got replaced by jet engines. So that created this, these were too big to scale down to civilian use. So that created, and that's gave time for civilian sector to move from 2-stroke to 4-stroke. So nobody started to like, this almost died out, as in like this was an engine, and then it just like quietly faded away. Now let that be clear, there is still hope, because again, the newer engines are still meeting emissions, even if dual piston opposed system and 2-stroke still can meet Euro 7. That is doable. So there's still hope for this sort of system. And this was another unique design I saw from one guy who has one website in 2017. Oh, let that be very clear. If you have a design and you patent it and all that, it expires in 20 years. So even if you see, hey, I can look into this and make some modification, go ahead. Most of them are expired patents, so you can go into it and just make sure somebody else has not patented that modification itself. So you can do it. Like you can do it. So future is interesting. It can work out. Again, I will put more faith in that army combat engineer, but rather than like in INNengine. It does not scale. Like how the heck you're gonna make it bigger? So let's see. This was a very unique 2017. He made a website and it's still working. So that is there. So this was a presentation on basically opposed piston cylinder engines. Hopefully you have liked it, learned from it. In that case, please see the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.